So today we will see about model interpretability using SHAP. So you guys are you had a session before, right? About SHAPs, So and you were applying SHAP in live before. So this is kind of a summary or a reminder. So while model training, if we are in order to get the best result out of a model, we do some kind of things like we different kind of things using a very good the quality of data, and then using different type of hyper tuning or fine tuning. So we will try to get the best out of the model. Then the next step will be if we want to understand how the model worked or how the model went to that specific decision or which feature plays the major role in selecting that specific feature, and then we will move to the feature importance and model interpretability, right? So they have the same concept. Feature importance and model computer interpretability have the same concept. So the part is when we came to SHARP, it's a unified framework for explaining the output of any machine learning models. So based on the Shapley value from cooperative game theory, it treats each feature as a player in a game, and the game in the model prediction. The game is the model prediction. The payout is the difference between the model's prediction and average prediction. And the sharp value fairly distribute this payout among the features. So the point is, or the idea of sharp is derived from the uh, Shapley value. So it will the type of players or like features or bodies that we need that we try to analyze is the futures and the future that we're going to predict. So it treats each future as a player, and the game is the model prediction itself. So winning the game is doing the model prediction way. So the payout is the difference between the model's prediction and the average prediction. The sharp value fairly distributes this payout among the features. So it provides consistent and locally accurate explanation for the result of that specific output or results. So why is it crucial? It's the first one is local explanation, which is it explains why a specific prediction was made for a single instance. Then they will give us a global understanding, which is aggregate local explanation to reveal overall model behaviors and future importance. So there are maybe like from your side, I would like to hear maybe if there is someone who would like to share what type of model interpretability have you used before? Like, what is your understanding on the model interpretability? Which part have you applied? For example, you might apply local explanation, and also you might compare uh, like the traditional way and the modern way, the feature importance and the SHAP model. So maybe if there's anyone who would like to share us what type of model interpretability have you used before? Also in line, which feature of line have you used on the before scenario? Would you like to tell us? Because it was applied on the previous challenge. Anyone? Okay, that's fine. We can go on. So where was I? Yeah. Then it's for a single instance, it will explain why that specific prediction was made. Also, it will aggregate local explanation to reveal overall model behavior and future importance. And the fairness is the bias detection. It helps identify if a model is relying on sensitive or unfair features. So if you notice, like if the prediction is like being dependent on that type of feature, it will make us to make a decision on removing, not removing, or making some decision based on the interpretation. On the debugging interest, it will facilitate model debugging by pinpointing problematic features and build user trust. So there is the feature engineering insight, which will guide improvement by showing which features are most impactful. So, sorry. So generally, It will help us to analyze which feature is important. So all the explanations or the importance will come from this explanation. So how SHAP works? So for each feature, SHAP calculates its contribution to the prediction by comparing the prediction with and without the feature. So considering or considering combinations of other features. So there might be five amount of features. So what SHAP do is literally we will remove that feature and we will try to do the model prediction without that feature. So if there is no that much change on the prediction of that model, this means this specific feature have almost zero effect on the model prediction. If there is a big difference on the model prediction, so this means this feature alone have a big impact on the feature. I mean on the prediction. So it will do for this for each feature, and it has varies this contribution to give the final SHAP value for that feature. So yeah, it has varies this contribution to give the finally we get the average value of those values will be the final SHAP value for that specific feature. So the key SHAP visualization we can use is the force plot, which shows how feature push prediction higher or lower than the base value for single instance. And the summary plot it will display the distribution of SHAP values for each feature across the dataset, indicating global importance. And the dependence plot will illustrate how a feature value affects the prediction of probability interaction with other features or with other dependencies. So we can use these three types of features. So that is why yeah, from different type of visualizing SHAP, we can gain or we can result. It can result from different type of analyzation or interpretation. So let's see one example of using SHAP, specifically SHAP for global interpretation. So we can start from yeah, we will start from importing or installing the libraries and importing the libraries. We will use the specifically the iris dataset for the prediction. Um, so yeah, the feature names here are the feature names or the data that we have. Okay, let's see them. So it's 150 by 4 the data shape. The feature name is these are the feature. The SEPA links reads the links in the data. This is a very familiar data. The target names are the species, which are the Setosa or versicolor or virginica. So these are the target names or the species of the dataset or the plant. So in the data visualization, we can see the distribution of like currently the data distribution that we have, which is plotted in a different way. So this will be just indicating both the all the three classifications that the cycles are the versicolor and the virginica. This will just plot the distribution. So and then there is the model training. Now we are using random forest classifier. So for maybe for decision tree type of models that we use and for logistic type of models that we use, we might use different type of interpretability or sharp interpretability. So it will depend on our decision tree, our model. So now we are using random forest for the model prediction. Here is the result that we have from the prediction. One accuracy, the recall, the precisions, the info score in the like here are the values. And it's like really very good prediction since it's a very little amount of data. I believe that you can also overcome. So in the analysis, now we can use different type of explainers. So now we are using for the explainer tree explainer, but we could have used the kernel explainer if the model was like regression or other type of model, which is not like which is not part of the decision tree models. Okay. So yeah, now calculating the SHAP value from the explanation, we can use the explainer to the SHAP values for every X text values or for our training or our testing data. So the SHAP value is now we're trying to print that. Let's see the output one. Okay, we run this, or we can just use the value. So the here the printed values are the SHAP value shape, which is 45, 4 by 3. The number of classes will 45 classes, number of case samples are 45, number of features are 44. That we use for the predicting the final value is 4. So 3 indicates for 45 indicates for the order data. 4 indicates for the for feature numbers, and 3 is the class that we're going to predict for the species. There are going to be 3 species. And then we're trying to use the summary plot here for graphing the SHAP values or the SHAP value that we've calculated here. Okay, so SHAP value and taking the SHAP value, the test values, and the features, we're going to summarize the outputs or the values that we have. So we are plotting here two types of, not two types of graphs, but two graphs. So what we're trying to learn from the two graphs is from the first, we're using the target names or including the target names. So we're trying to specifically see features, or now we're trying to make global explanation. Okay, so it will tell us what that feature or what features have an effect globally, or on all the data. Okay, locally we could make feature to feature interpretations and that type of interpretation locally. So on the global features, on the first we're trying to see, so every features might vary or their effect or uh, their effect on the distribution might vary on different areas. Okay, so it will tell us the first one will tell us that, and the second will tell us which feature will have the or the bar chart here, uh, which features have the the most effect or the most the most effect on the prediction. So there's the like in every type of on the vertical or whether it is vertical or whether it is horizontal, the feature that we take first is going to have the most or the high impact on the prediction or on the model prediction. So in the first we get the safer links, the critical links, and the safer links. So this show us, this is the plot summary for the first one. We just use the class names as target names, and the other is the same. On the second one, we just use the plot type as bar. And so this will tell us not that the safer links have the highest effect, but rather this will tell us that safer links have high variation of the like sometimes it is one of the most uh, so we have different instances prediction, right? So here we can see that sometimes the safer links will have the most effect on the prediction, but sometimes you don't have that effect on the prediction. But the main or the sharp bar plot will tell us there is a high effect of the beta widths. The beta widths have the highest effect, and the beta links will follow, and the safer links will follow. So we have these three different classes. So they take on every instance on the class 0, on the class 1, on the class 2, which feature had the most effect. So this will tell us constantly on all the instances or on all the predictions which feature which feature have the most effect on the model prediction. So here we can see that the beta widths have the most effect on the model prediction, but the safer links have the most variation or it varies the most on the model prediction along all the instances. Okay. So basically, you have also tried the feature importance. So literally, feature importance means the traditional way of SHAP or model interpretability. So you can see from this, or we're different if we have a bigger data or something, you can see from that data which model is going to have the most effect on our model. And if you need to make a decision based on that, getting back to model prediction, then you can make that type of decision again. So in short, so like seeing your submissions before this, maybe most of you have tried the different type of sharp prediction. So you can like starting from the global prediction or the global interpretability, you can go down to the local ones. You can go down to the different type of explanation you have. So yeah, uh, this is just how to make a global explanation. So yeah, if you have any question, we can go on. Is that clear? Is that clear? So like was that clear? Well, or was it already clear before because you've seen how to do shop? Any type of instruction would be good. Okay, thank you. That's the another one. No, you could go.
So, am I audible?
Yes, you are.
Yeah. Okay. Thank you. Yeah. First time that we become familiar is in insurance risk analysis. So in week 3, and I tried to graph the summary plot and waterfall plot. But what I see is from the waterfall plot there is a negative and positive amount of impact on the prediction, and in summary plot there is only green and red colors. So I think can we say there is a difference between what we get from waterfall plot and summary plot, or are they the same? Hello? Hello, are you there?
Hello, Nurji. Hello. I'm sorry. I guess. Hello.
Hello, hello.
I'm audio, right? Yeah.
Yeah, you are audible
I'm
now.
sorry. So I guess you were asking if there is a difference between the you have used the summary plot and what was the
Waterfall.
other plot? Was
Water.
the water. Okay,
Yeah.
maybe can I ask what type of like what type of explanation were you trying to do? It is the global interpretation or what? Or the
Uh,
local interpretation? What specific
I think
type
it's
of
a global
interpretation?
one. It's a global one, I think.
Yeah. So yeah, I believe there's a key difference for like the water float graphs. So like the output from the water float graph will be on red or blue bars, right?
Mm-hmm. Yeah, yeah,
So the positive or the negative effects it will impact to that direction. So on the summary plot, it is the red and the green dots,
yeah.
and it indicates for high or low measurements. So uh, for the waterfall, which if the color is red, it have a positive impact. That feature will have a positive impact, and the blue will have a negative impact. And for the plot summary, if you have the red, it will indicate that high feature values, and the green will indicate the low feature values. So the right means positive, and the left means negative. So I guess the point is there's a different on their color meanings, but what the positivity or the negativity is and what the positive impact and the negative impact and what the high feature value and low feature value are trying to say is the same thing. They are trying to say that feature is more important and that feature is not important, but there's just a difference between the meaning of the color.
Okay.
Am I clear?
Yeah, it's somehow clear.
Thank you. Any other question? Is there any other question? So, so yeah, you guys need to try to do this different type of like use different type of proteins or and graphs and try to read like their interpretation in a different way. So yeah, you can experiment and on the global on the local explanation, or also don't forget to include that. So yeah, I guess you it would be an easy concept. Thank you guys for being here. Um, don't forget to leave up to Slack if you have a question. Then I'll